Okay, this video is going to continue our little three-part mini-series on thinking procedurally. In the last video, we spent quite a bit of time working with common everyday recipes, showing how you could switch around a few of the ingredients and come up with different types of results. We're going to continue the discussion of thinking procedurally in this video with a look at numbers. Like I said at the very beginning of this course, a basic understanding of math is important. So let's play around with a little bit of math in this video. Okay. Now, not every network that you work with inside of Houdini is going to be represented from top down. So far, we've seen these types of networks, correct?
Right.
So in this video, what we're going to do is we're going to look at networks that are going to go in this direction. Sound good, Terry?
Yeah.
I just want everybody to get comfortable visualizing networks in different directions, because in Houdini, you're going to see both of these directions right here. So let's go ahead and clear that. Now, since we're going to just jump right in and start making a bunch of networks, what I'm going to do is bring up the nodes that we're going to have available to us. Da-na-na. We've got add, subtract, multiply, divide, power, square root, parameter, and constant. Okay? Now, parameter is just going to allow us to simply give the node a name and inject any kind of value that we can change. So if I wanted to say A plus B, Terry, is this starting out simple enough for you?
Oh, yeah.
Okay, good. What I could do to represent this in a node network is use a parameter node. So this will be node, I'll just put A right here. And then another parameter node, this will be B. And then I can use, what kind of node do you think I'm going to use right here?
I'm going to use an addition node.
Oh, very good. So we'll take an add node, and we'll put an add node right there. And now I can simply connect A, connect B, and then on the output, what will be coming out? Well, A and B added together. So if I was to come over here and say that we had 5 and 6 going in, what are we going to have coming out over here?
11.
We're going to have 11. Very good. So your math skills are kind of in tune today?
Sure.
You're not stressing, are you? So if we were to sample what was on the line right here, what do you think we're going to find?
What, the number? You're going to find 5.
You're going to find 5. Okay, I just want to see how you visualize this in your mind. So if I had some kind of meter that I could put on the line,
I gotcha.
What are we going to see right here?
That'd be 6.
That'll be 6. Very good. And same thing here. If I had a meter that I could put on the line over here, I would find 11.
Right.
When working in networks inside of Houdini, what we're doing is working with data, and we're passing that data through all of these different network lines from node to node so that we can continue doing operations on the data and then passing it off to the next node.
Right.
So I want you to start thinking of what data is on the line. And in this case, we've got 5, 6, and finally 11. So that's pretty simple, right?
Yeah.
All right, so let's see if we can make it just a tad bit more interesting. So let's go ahead and hide this layer right there. We'll add a new one real quick, and let's jump over here. And I don't know, something like A multiplied by B divided by C. Okay? So what are we going to need first, Terry?
Well, you're going to need a multiplication node, obviously.
Okay, we're going to need a multiplication node. So we'll go ahead and just, see, that's the nice thing about working in Houdini. You can just toss that down. So I'll just represent it with a big X.
So it doesn't matter what you lay down first then?
No, you can throw all the nodes down. It's no different than if you're going to start cooking one of those recipes that we looked at in the last video. You can go in your kitchen and take out your milk, your sugar, and all that, and just lay it all on your counter.
Okay, because I was going to say I forgot to put the parameter nodes in first.
So now we want to go ahead and put some parameter nodes in?
Right.
How many do you want to put in?
2.
Just two?
3.
3, okay.
Right.
So what's this parameter right here?
Well, that'll be A.
All right, very good. This parameter?
You can make that B.
Okay. And you said you want to put in a third one?
Right. Let's put in C because you're going to divide A and B's final product into C.
Okay.
By C, excuse me.
So I'll go ahead and draw my little inputs here. And we've got one output coming out of our little parameter nodes right here. So I can take A and plug that into my multiply divide node. I can take B, plug that in. Now, what do I want to do with C? Well, looking up here at our little equation, let's think about this as a network. Well, we want to multiply A and B first. So this is going to occur before the division. So now that we have these things multiplied, let's divide C into it. So we've got the result coming out, and we can throw down a divide node So here's our divide node. So here's 1 coming in. Here's our other input, and we'll take a connection and see if we can make this look kind of nice. There we go. So you can kind of think of this as input 1 and this as input 2. And then if you were to say, well, what does this node actually look like inside? You could say that it's input 1 over input 2. Okay? So let's say that we had something like A was equal to, 10, and we had B equal to, 6. So we've got a 10 right here. That's in A. And we've got 6 in B. And we have 2 over here in C. So if I was to sample the line, Terry, right here, what do I have?
10.
Very good. If I was to sample the line right here, what do I have?
You got 6.
6. If I was to come way over here and sample the line, what do we have?
2.
2. Very nice. Now let's trace this data through the network. So we have 10, as you said, coming into the top of our multiply node right here. Okay, so that's 10. So again, here we are taking a look inside the node. So that's 10 multiplied by, and coming in the bottom, we've got 6. So that's 10 multiplied by 6 equals what?
60.
So it equals 60. If we were to sample right here, what are we going to get?
You're going to get 60.
We're going to have 60. Exactly. So now we have 60 coming down into our divide node. So it's going to be, well, using this right here, we're going to have 60 over, now who's coming in on the bottom?
2.
2. So 60 over 2 is?
30.
30. So coming out of our node right here, we're going to see, if we sampled it, that we'll have 30. Does this make complete sense? How I'm laying the nodes down, I'm connecting them up, and how we're tracing the data as we go through the network.
That's right.
No questions.
No questions.
Completely clear. All right, so let's see if we can make this a little bit more interesting. So jump over here. We'll go ahead and hide that out and make a new layer real quick that I can draw on. And let's do something really simple.
Okay.
About A times 5.
Okay.
Simple. So in this particular case, A is a parameter because A can change. 5 is a constant number.
Okay.
That number is not going to change. It's not being represented by a variable as we have over here. Okay. So A is represented as a variable, but it can change. So let us go ahead and first throw down a parameter node. So this will be A. And now what we're going to do is we're going to use a constant node because, again, we're dealing with a number that simply does not change. So let's go ahead and throw in a constant node. And I'm just going to represent this by just throwing 5 inside of opening and closing parentheses there.
Okay.
So now, what else do we need?
Well, if you're going to multiply them together, you need a multiply node.
Multiply node. Very good. So we'll come over here. We'll throw down a multiply node. And again, we'll drop in a few inputs, some outputs, and we will connect up our different nodes. And then we'll push the data through the network and see what we get. So let's just stipulate that at the moment, A is 2.
Okay.
That means we've got 2 inside of A. So once again, if we were to sample right here, what do we have?
You got 2.
We got 2. If we were to sample the line right here, what do we have?
You got 5.
Now inside of our multiply node, we have 2 being multiplied by 5. So coming out of here is going to be what?
10.
10.
So would the constant node have any parameters in it whatsoever?
Nope, just a value that you can set.
Okay.
And its job is just to always maintain that value. So you may run into conditions or situations where you're going to need to multiply something by a particular number that won't change, and that will happen inside of Houdini. And you're not always going to want to add that extra node, how we've gone in and we've added a constant node here. So there is another node. Not that we're actually teaching Houdini at the moment, but Houdini does have a multiply node. It also has a multiply constant node. So another way that this network could have been done, let me make a little bit of room here. So we'll erase this area where we were sampling. We could have done this. We know for sure we need some sort of multiplication node. Okay?
Right.
And we know that we need a parameter Because here we are with A, and that value can change. It can be whatever.
Right.
Okay. But we know for sure that we're always going to multiply A by a constant, by a number that's not going to change. So there is a particular node, which we don't have over here. Let me push that back over a little. That I did not draw, because I wasn't going to throw this in, but what the heck. I'll just, this will make things clear for you. And it is known as a multiply constant. So I'll just put multiply constant. And the way that node works, check this out. It has your input, and then it has a parameter that you can set that is the number you're going to multiply the input by.
Okay,
so that is your constant. So in this case, I could have used that node, put a 5 in there, simply hook this up, and then what's taking place inside the node? Well, you've got A being multiplied by 5, because that 5 is a parameter that's been set, okay? And A, of course, coming in the example we gave above is going to be a 2, so you'll have 2 times 5. You'll still have 10 coming out. But what's the difference between these two networks?
Well, you have a cleaner network, but you can also hook up many different parameters into that one constant node, correct?
Well, into the one constant node? Well, let's just keep this real simple. Okay, real simple. We've got a cleaner network. I have managed to come in here and remove one of the nodes, one of my connection lines, and I've made the network look a lot simpler. It's a lot easier to read. Let's just leave it at that. Okay? And we're going to slowly build. I don't want to jump too far ahead. So there's two different ways of doing the exact same network. When working in Houdini, there are multiple ways to do just about every single thing. And some of the things may have hundreds of different ways that you can go about approaching them. So, very simple network. Now let's see if we can do something else. Any questions about this?
No.
Okay. So let's jump in here, and once again, we'll add a new layer so that we can do a little bit of whiteboard scratching. All right, let's see. Something a little bit more complicated. You ready for complicated?
Sure.
A times B. All right, let me think. How do I want to do this? All right, we'll do A times B over C. Multiply this by, how about 1 over A? And then let's multiply this by C.
Okay.
All right, so a little bit more involved, and this is going to be the first time that we're going to get to see some interesting stuff where we can actually route data in different directions from one node. And this is so powerful, and we will be doing this a lot in Houdini. Okay, so with this right here, and that is a multiply for anyone who was sleeping just a second ago when I explained this. All right, so to write this out, what do we need to start with?
Well, you're going to put down your constants.
All right, well, in this case, we've
the parameters. I'm sorry, I meant to say parameters.
Okay, we've got some parameters. So we've got A. We've got, A's used twice. Do we want to put it twice?
No, actually, because that's a good question because I haven't written out the network yet.
We're not going to put it. We're not going to draw it twice. Actually, I'm going to move down a little bit because I'm going to need room above. So watch this. We're going to do A. We're going to do B. And we're going to do C. Now, we do have a constant. What is our constant when looking at that equation?
1.
1, very good. So we are going to need a constant at some point. We'll throw him in just a minute. But let's start simple. Let's just focus on the very first part. We've got this right here, A times B. So let's go ahead and come in here and throw down, what node do you think we're going to throw down?
Multiply node.
A multiply node, very good. So take these guys. This will be a multiply node. In, outs. Getting everybody very comfortable with the idea of connecting networks. So out to in. All right, so there we go. We've taken A and B and we've plugged them into a multiply node. Very good. Now, how do we want to approach this? Again, this comes to the whole thinking procedurally thing. Well, we know that basically what's going to happen is A is going to be multiplied, that looked rough, by B, and the result will be divided by C. Okay?
Right. So you have to put a divide.
So we're going to need a divide node at some point. So let's go ahead and clean that up a little bit. So we can come over here and put a divide node in, making sure I give myself plenty of room. So the result coming out of here, our product is going to be divided by
C.
So we can go ahead and run C on over, up, and in. So far, so good. Now we can move on to the next part. Multiplied by 1 over A.
Right.
Ooh, interesting. Check this out. So now I'm going to need a constant. So this is a constant node I'm going to represent by setting the parameter of what the value holds in the constant. It's going to be a 1, so there's my 1. And we know that we're going to have a divide node because it's 1 divided by a, so let's go ahead and throw in a divide node.
Oh, okay, I see. All right. I just had a revelation. Eureka moment.
Very good. So now we can just say, all right, constants. This guy is going to be divided by, so we plug him in on the top. Here we go. Very important moment for all of our Houdini beginners out there. I can tap off A again and bring A all the way down.
What confused me was that you had the 1 over a was behind another multiplication node. So I didn't know that if the you were going to have to get the result. That's what confused me.
Okay, gotcha.
Yeah.
All right, but so far are you with me?
Oh, yeah, it totally makes sense now.
So let's play the sample game. If I sample the line right here, what do I have?
You have A.
I have whatever's A. Very good. If I sample the line right here, what do I have?
A.
I have A. Very nice. Exactly. That's the key thing to understand. Then very powerful when we get over inside of Houdini and we're working. Let's say that we needed a sphere, right? And we're going to take and we're going to modify that sphere and do all sorts of stuff in the network. Then later on, we need another sphere. Instead of adding another sphere node into the scene, I can come up here and branch and treat it differently. And later on in the network, these guys can be merged back together.
You just blew my mind.
Did I?
No, that totally makes sense. But
because it's just one sphere that I'm using in two different ways, and I'm taking the results and putting them back together. Haven't I just done the exact same thing with A? I've taken A, and I've done stuff with them in one direction. But now I've taken A, and I'm about to do stuff with them over here.
That's right.
And we can see that branch right here. Okay?
Right.
So again, and of course the way this is represented in Houdini is more or less so here was A, you got one line that's going to go off that way and one line that's going to go off that way. It's as simple as that. Okay? So now we have 1 over A. So we're handling this part right here, in its own little network piece.
That's right.
Now, what are we going to do? We need to take these two guys, the result of him, the result of this whole section right here, and what?
Multiply them together.
Multiply them together. So let's go ahead and do that. So we can simply take this guy over here into a multiply node. And we can take the result of the division over here and run that in. So now we're multiplying them together. So now we've got all of this complete. So we're just left with multiply by C. So here we are in another case, this is fantastic, where we're going to get to reuse C. So to multiply, so we're going to need another multiply node. There's our inputs. So we're going to multiply the entire result of A multiplied by B divided by C, and the result of that multiplied by 1 over A. So we'll take all of that, put that in there. And then we're going to come off from C. So here we are once again, and I'm tracing the line. So we've got another wire coming off, over, up, over, bink, plugged in.
There you go. Cool.
And then the result out is whatever it's going to be. Sampling the line at multiple locations. What do we have right here, Terry?
C.
C, very good. What do we have right here, Terry?
C.
Very good. What do we have right here?
You have the result of C, the math that was the result.
Got you on that one. So what do we have right there? To be honest, we have A times B over C, right? Okay, very good. What do we have right here?
You have the 1 over A.
1 over A. Outstanding. So now you're starting to look at this network and being able to understand what can be found at any given point, right?
Right.
Fantastic. So let's play with some numbers. Let's have a little bit of fun here. So I'm going to just put a little dividing line in here. Let's say that A equals 2. B equals, hang on, working it out in my head real quick. Oh, this will be simple. B equals 8 and C equals 4. So what if we were to pump this to our network? So let's see what we've got. So we're going to have 2 sitting right there. Agreed?
Right.
Okay, because we've got 2 over here.
Right, I'm trying to make connections between A and 2 now.
That's cool. In B, we've got 8. And down here in C, we've got 4.
Right.
So let's trace it through. So we know we got 2 there. We've got 2 sitting up here. Sitting down here, we've got 8. So if we were to to peek into the multiply node, we've got 2 times 8. So what do we have coming out?
16.
We have 16 coming out. Very nice. Okay, down here on C, we've got 4. So we've got 4 sitting right here.
Mm-hmm.
We've got 16 right here, correct?
Right.
Because it's traveling on that line. So now we've got 16. So once again, let's take a look inside the node. The node's job is to take first one coming in, input 1, over, input 2. So 16 divided by 4 is?
4.
So we've got 4 coming out. Very nice. All right, let's move our attention up here to this guy. So inside the node, what do we have? We have 1 over 2. What's that?
2.
That's a half.
Yeah.
That's 1/2. So it's going to be 0.5, right?
Right.
So I have 0.5 coming out, which means we have 0.5 sitting over here, and we have 4 over here. So what is 0.5 times 4?
4 times 0.5 is
It's half of 4.
I don't know, 2. It's
Okay,
2.
very good. So we've got 2 over here. All right. Now let's come all the way back down here. So here's our 4. Okay. That 4 is trucking right along. Still got 4 trucking right along. So we got 4 over here. So now we've got what taking place inside this final node?
4 times 2.
2 times 4.
Or 2 times 4.
Yeah, I'm just reading from top
Now-
input down.
Okay, now that brings up a good question.
So what's my output?
8. 8. Excuse me. Sorry, I'll answer before I ask a question here.
All right, so hang on. I'm about to let you do it, I promise. Let's
Okay.
take a look at this. So watch this. Some little bit of simplification. So A times B over C times 1 over A times C, which can be represented as C over 1, right? So we can just say take A, cross that out, take C, we'll cross that out. And now we're just left with B times 1 over 1. So that's just B. So that's equal to B over 1, which is just B. What was B?
8.
Aha. What was our result?
8.
Ha.
See, yeah, the reason I was joking earlier, just, doing lightheartedly is because this is a very complicated math, so to speak, but explained extremely easy.
Okay.
So, I mean, it's amazing that you can pull all this together through a network like that, and it's just common sense stuff is what I'm getting at. It's like all of it is if you just sit back and think about it.
Just think about it. That's the key.
It just step at a time, it'll come through. Now, the question I have was because I said 4 times 2 and you said 2 times 4 because of the way you're looking at it.
It's multiple. Yeah. When you're working with nodes, order becomes very important.
Okay, that was the question.
Okay. Yes. Because think about this. In the multiplication node, this guy right here, is it going to matter? What's 2 times 4?
It's 8.
What's 4 times 2?
It's also 8.
Aha, so the order doesn't matter there.
Right.
All right, so over here with this guy, we had 16 divided by 4, which gave us 4. But what if it was 4 divided by 16?
Exactly, and that's what my point was, that you'll get a different outcome if you have it switched around.
That's right. With certain nodes, the order is extremely important. And, of course, we'll get into that heavily as we move into the world of creating nodes in Houdini, or networks in Houdini. So a little bit more sophisticated of an equation here. But does it make complete sense after we laid the whole thing out?
Oh, definitely. It's just amazing that you can look at something, because obviously you're not going to be having a very light mathematical equation like this through it. Well, you may very well have it through a network in Houdini.
You might have a light one like this.
But it's just, if you just step back and take a look at it, it makes complete sense.
All right, well, let's see if we can build on this. Let's see if we can make it a little bit more interesting. So once again, let's jump over here to my layers. We will turn off visibility for that layer, add in a new layer real quick. So at this point, we have used, hang on one second, we've used add. Have we used subtract?
No, we haven't used subtract. But I mean,
we've used multiply, we've used divide, haven't used power, haven't used square root, we've used parameters, and we have used constants, right? All right. See if we can make things a little bit more interesting now. What I'm interested in doing is setting up something that is going to, I have to think how this is spelled real quick, Rean. So the Pythagorean Theorem. Do you remember what it was?
Yeah, I think it was a squared plus b squared equals c squared.
A squared.
It's very simple.
Plus b squared equals c squared.
Right.
All right. So now we're getting into some fun stuff. So can we represent this in a network? Well, we want to solve for something. So in this case, we would want to solve for, let's say, c. So we could simply say that what is c? C would be equal to the square root of a squared plus b squared. How did I come up with that?
Oh, are you asking me? I'm sorry. I thought you were just in general asking.
How did I come up with that? I just simply took the square root of both sides, so that everything stayed equal. And, well, the square root of c squared is just c.
Right.
Okay, because c times c, okay, gives us c squared. So and the square root of c squared is just c. So that simplified down to c equals the square root of a squared plus b squared. Now, for our students out there, and for you as well, Terry, like I said at the very beginning, we were going to have some math involved here, okay? This is very simple math. We were getting to more complex math a little bit later, all right?
Can't wait.
I bet you can.
My brain is straining for high school right now.
So what we're looking at is how can we come in here and do, an a squared plus b squared type thing. So once again, we're going to start out with some parameters to represent this. So let's say we've got a, and let's say that we've got b. Now, C is a piece of information that we're looking for. It's going to drive something else.
Right.
Okay? So how do we get this right here? Well, check this out. What I'm going to do is I'm actually going to draw this a little bit differently. Watch this. I'm going to come in here, and I'm going to move B down to here, and I'm going to give myself some room. And this is going to make a lot of sense here in just a second. So let's go ahead and clear B out. So we've got a mystery node right here.
Okay.
All right. So what I'm going to do is I'm going to come up here, and I need to get basically a squared. I need to get the result of that. So what I'm going to do is I'm going to use a power node. And the power node takes in your base and your exponent. Okay? Just for those of you that may not remember, Terry. Base, exponent.
Okay.
Are you with me?
Yes.
All right. And honestly,
no, I know what base and exponent is.
If at any point you're not with me, just let me know. So let's go ahead and take our base. So that's going to be A, and we'll simply plug it in. Now, I'm going to use a constant to drive my exponent input on power.
Okay.
So we'll take this 2.
And that makes sense because all of our exponents in here are, of course, squared.
That's right. They're all 2 to the power of 2. So we're going to say take A to the power of 2 and give me the result. So once again, this guy right here is going to be my base. And this guy right here is going to be my exponent. Make complete sense?
Yes.
All right, very good. So now let's go ahead. We got to do the same thing because all we've done with this section is what? That. Okay, or we could say that, a squared. All right? So let's go ahead and move all that out. So now let's take a look at doing B. And again, translating this over to a network. Again, we're using a power node. That's going to have a, let me draw these out now. They'll look a little bit better. So we're going to have a, top one is going to be our base or value coming in, and the bottom one is going to be our exponent. So what is going to be our base? Our base is going to be B.
And you're just going to use the 2?
And here we are reusing this node. So we'll come off and plug him in down here. So now this section of the network has just accomplished that. Completely with me so far?
Oh, yeah.
So all of this has just accomplished that and that.
There you go.
But we still need this.
Okay.
We got to add them together now.
That's right, yeah. There you go.
You got to make sure that when you're putting networks like this together, don't overlook something, okay? So in this particular case, what kind of node are we going to put down?
You're going to put down an addition node.
An addition node. So we're going to throw an add node in. Okay, inputs. So we'll take the result of A squared. And we'll take the result of B squared. Fantastic. So now, coming out, this entire network has accomplished that.
There you go.
Okay? So, now we just need to get the square root of it. And we happen to have a square root node over there. All right. So let's just use a square root node. So we can take this guy. QRT for square root, pump them in, and going out, there you go. All right, so how are we doing?
Doing all right.
Nope.
See, that makes sense because you're reusing the constant that you have over there for the what is it? Excuse me, the exponent. Wow,
exponent.
Exponent.
Yeah, that's
you're
right.
using that over and over again.
Yep. So we don't have to lay down more constant nodes.
That's right. So yeah, that totally makes sense.
All right. So let's go ahead just for a second and clean this up just a little bit. So everybody knows that's the base now, and everybody knows this is the exponent, and we all know. That is. All right, very nice. So let's give some numbers.
Okay.
So we'll just use a very common example. So let's say that A was equal to 3.
Okay.
B was equal to 4. And we know this is a very common example that the Pythagorean theorem applied to a triangle with a equals 3 and b equals 4 is going to be a result of 5, okay, for our C side. And what I'm talking about for those out there. So, we know if we know that that's 3 and this is 4, this is going to be 5.
Yeah, okay. I'm just getting flashbacks of goofing off in junior high, and I regret every bit of it.
So let's follow this through. So what's on the network right here?
That would be, of course, A is 3, so 3.
All right, very good. What's on the network right here?
That would be 2.
That's 2. Very nice. Inside this node, what do we have?
A squared.
Which is 3
to
the power of 2.
Mm-hmm.
So what do we have coming out?
9.
Oh, very good, Terry.
You're surprised that I can do math.
Thought I was going to get you there.
Rightfully so, actually.
All right, so right here, what do we have?
What you point? Okay, that is 4.
Okay, so we're going to have 4.
Mm-hmm.
Very nice. And what are we going to have coming in down here?
That should be, what is that, squared, so 2.
2? Squared?
I'm sorry, 2.
The value coming from the constant. Very good. Okay, so work being done inside here, what do we have?
You have 4 squared.
So 4 squared. 4 to the power of 2. Very nice. So what do we have coming out?
16.
Okay, I won't act surprised this time.
Yes.
Because I expect you to get it now.
You're just like, whoa!
All right, so now those two are going into an add node.
Right, so you have 9 plus 16.
So what do we have coming out of here?
22. I have no idea. No, I'm kidding. Is
16, 17, 18, 19, 20, 21, 22, 23, 24, 25.
Sure. No, you're absolutely correct.
Okay, Terry, just for you, I shall bring up a calculator, and 16 plus, what, 9?
Mm-hmm.
It's 25.
Amazing.
It's amazing. Okay, so coming out of the node, what do we have right here?
25.
25. So what are we seeing inside this node over here?
Square root of 25.
So what times itself will give us 25?
I'm not even going to pretend I know how to do square roots. No, I know how to do square roots, but I was never good at it.
So 5.
It would be 5.
Is what's coming out.
Mm-hmm.
And that is one of those scenarios where it is a 3, 4, 5 triangle. Okay? Makes sense.
Oh, yeah, completely. Joking aside, this is very, very straightforward. And you do have the networks that you are laying down will obviously, like I stated many times earlier, it's common sense.
Okay.
Just kick back and, step at a time, and it will make sense.
This is really good. I hope our students that are watching these videos really understand that the relationship you and I have right now in the recording of this is truly an instructor-student relationship, because I really am asking you questions that you don't know I'm going to ask.
On the fly, yeah.
I was really hoping that you were going to get 9 wrong. Okay. So anyway.
That just baffles me. It makes me sad that you think you can't do math.
All right, let's move on to something a little more interesting. Let's use the Pythagorean theorem now in a distance network.
Okay.
Even though we do have a distance node available over inside of Houdini, we're going to construct an entire network ourselves. All right?
Mm-hmm.
Just goes to show you the power of Houdini. There's nodes for almost everything. All right. So let's come in here again. So like I said, we're going to be looking at a distance network. So what do I mean when I say we're going to be looking at a distance network? Okay, this is where things are going to get really interesting. Let's see if I can draw something that looks kind of halfway decent. Let's say that here we are with a plane. Okay, so we've got going left and right is going to be our x, and up here is going to be y. And we had an object, obj1. That's going to be object number 1. That's located 4 units out over there. And we had an object located up here that, let's say, is 3 units up. Okay, so this is going to be, let me see, how do I want to write this all out? OBJ1, everybody, let's stipulate, that's object 1. And this is OBJ2, object 2. Okay. What I want to do is come up with a network that is going to allow me to calculate how far apart they are, the distance. And this really does simply get over into Pythagorean's theorem again. So we're going to be recreating what we did in the last section, where what we're looking at is, here's one object, here's another object, and if we connect the lines, and this guy goes straight down, this guy goes straight over.
Oh my goodness, you made a triangle.
We have a right triangle, which means we can now calculate this distance, this length, this leg right here, if you will. Okay? So how do we do that? Well, we know that basically to come up with C is going to be equal to what? Jumping back to the Pythagorean Theorem real quick, C is equal to the square root of A squared plus B squared, right?
Right.
But looking at this guy right here, it's like, well, what is A squared and what's A? What's B? All right, well, let's break that down a little bit. First of all, let's take a look at object 1. So I'm just going to give myself a little room by backing up over here. So OBJ1. So the first object is located at X, he's 4 units over. Y, he's 0 units up or down. Okay? Does that make complete sense? Okay.
He's right there on the line.
He's right there on the line, so that's why Y is 0. So let's take a look at OBJ2. So object 2, fill these in for me. Where is he in X?
He is in in X, excuse me. Yeah, he would be in 0, right?
That's right, because he's not moved either way. He's just
right there on the line.
Moved up. So he's going to be 0. And how far is he moved in Y? That would be 3. Very nice, Terry. So there we go. So this is the location on a 2D plane for object 1 and object 2. And I need to calculate how far apart they are. I just need a single number. How far apart are they? Okay, so how do we apply this? Well, to come up with A, to get A, basically what we're going to do is say, and I'm going to just represent this just to keep things easy, X, because we're dealing with X and Y basically. So watch this. If I say the X of the first object minus X from the second object, and then that will give me a single number. And then I can square that. And there's my A squared. Okay, so we could say A squared is equal to that. So that means what is B squared? Well, let's do the same thing. But now we're dealing with Y. Okay? So, because in the end, going this way, we're dealing with X, and going this way, we're dealing with Y. So now you see why I'm looking at X and Y now? So for B, we're dealing with which one?
You've been dealing with Y.
Dealing with Y. So now over here I can say we're going to take Y of the first object, and what if we subtract away from that Y of the second object, and then take the result of this and squared it? You with me so far?
Yes.
And that gives me B squared. So that means our actual formula for the distance right here is going to be as follows. So we're going to have x1 minus x2 squared plus y1 minus y2 what? Squared. Very good. And then I'm going to take the square root of this whole thing. I know for those out there that are scared of math, this is going to look like I've just done some crazy stuff. It's like, it's crazy, man. It's crazy. It's not. It really isn't. You just have to take a deep breath and think about what we're doing here. Okay? It just looks complicated. It's not.
That's right.
Go impress your mom. Show her that you learned something cool from this video. So check it out.
The internet's not all bad.
That's right. So this is, because the bottom line is this. I mean, we're dealing with two sets of numbers. How are we going to plug that into this guy? Okay? Well, now, if we were to break this down, it's real easy just looking at it, because X, we're looking at 4, and we've got 3 over there on Y. So we already know we're looking at a 3, 4, 5 triangle. So we better have a distance of 5. But I'm cheating right now because I'm just looking at it and I'm saying, hey, it's a 3, 4, 5 triangle. Okay? But let's put all this together and let's trace it through. So here, this might seem a little bit convoluted, but let's do our best. So A. What is A going to be equal to? A is going to be equal to, I'm going to take object 1 dot X. That's just how I want to represent this.
Right.
So object 1's X is what? So this is going to look like some funky math here. Okay, this is, again, my way of drawing this out. It's what? So object 1, X.
Yeah, it's along the 4 axis. Or 4 axis. It's 4 along
so
the
we've got 4 along the x-axis. Then we're going to take away from that what? We're going to take away object 2 dot his X, which what was that?
That was 0.
So that was 0. So what are we really dealing with here? We are dealing with, so if we were to move this on over, it would just simply be 4 minus 0, right? So let me erase those out just because we all know that is equal to 4. Okay? But we know that this is squared. Because this whole scary looking thing right here is this. Just this little piece right there. Okay? So that's actually 4 what? 4 squared. So I'm just going to write it like this. I'll keep my 4 in the parentheses just for clarity.
Okay.
Squared. So what does that equal to?
16.
16. Wow, look at this. We've turned crazy looking numbers, some coordinates, into just the number 16. Very nice. Let's take a look at B. So B is going to be equal to what? Well, object 1, let's start with him. And let's take a look at his what?
His y-axis.
His y. Very good, because now we're dealing with just y. So what was his y? Very first one. So
excuse me. I'm sorry. It's 0.
So it's 0. We're looking at this guy right here. Very good. So we'll take 0 minus object 2. Let's take a look at his y. So object 2's y component's what?
3.
3. Very nice. And of course, to finish off the whole thing, it's actually squared. So what's this equal?
That would be 9. Well, I'm sorry, 3 squared.
All right, well, let's break it down. 0 minus 3 equals
3.
minus 3.
That's right.
Because we start with nothing.
That's right.
And we take 3 away from nothing. We're left in the dirt.
That's right. We're like 5 answers just flew out of my mouth.
We're left in the red. So we've got a negative 3. Okay? So now what I'm going to do is I'm going to come over here and say negative 3 raised to the power of 2 is equal to what? So minus 3 times minus 3. Well, these two guys are going to end up getting turned positive, right? Negative times negative. So what's 3 times 3?
9.
Outstanding. So the result of this will indeed be 9. Now, to finish this off, because basically this part of our equation is this section right here. Okay, all the way out to there. This includes the power of, all right, our exponent. So now, from the first one, we had 16. From the second one, we had 9. We can't forget our addition operation right there. So we do these two guys. We add them together. What do we end up with?
Oh, I'm sorry, 25? I'm sorry.
So we end up with 25. The square root, because all of that resides in the square root, is what?
It was 5.
Gives us 5. That's right. So we're left with 5. And we know this was a 3, 4, 5 example.
Trying.
All right. Are we ready to turn this into a network now?
I would love to see this into a network, because right now, in all honesty, as simple as this math problem is, and everybody should know this through junior high, that is very intimidating. If someone just walked in the door and looked at that with, no prior knowledge of what you're doing, that right there would blow you away.
Wow, we're doing some really sophisticated
Jimmy
math.
is smart.
So let's do this.
Okay.
See if I can give myself a little bit of extra room, because I'd like to be able to draw this all right here. So how do we put all of this together? I'm going to introduce a new node, just to simplify things. So we'll pretend we have that node up here. And this is going to be an object node.
Okay.
I'm just making this up, guys.
Oh,
okay. So this object node is going to have an x and a y out. That's the reason I'm doing this.
Okay.
Okay? So x and y, that means I can simply contain one object and one node, one object and another node, and I don't have to use a whole bunch of parameter nodes because I have very little space down here.
Right.
All right, so to draw this, let's start out with object 1 and 2. So here we are. Our first one, make sure I have plenty of room to draw this. So OBJ1. And then let's come down here and put in OBJ2. Okay? So object 1, we know that this guy is at 4, 0. And object 2 we know is at 0, 3. So far so good, Terry?
Yeah.
Now, like I said, coming out is going to be an x and a y. X and a y. I'm simplifying everything. So what do we need to do? Well, we start out, let's focus right in here, okay? All right, we've looked. Now we're going to move up and focus at a lower level, right in here. Okay. Now let's focus even tighter. How do we start out the whole thing?
I see. You're going to have x minus x squared.
Very good. So we've got some subtraction. It's our very first operation that's taking place. Again, thinking procedurally, you have to break this down in your head. Look at this and say, all right, It's a big formula, but what's taking place first? Okay, the order of precedence. Let's think about that. First thing we're going to do is what's taking place inside of our parentheses there. So we have simple subtractions. Don't let this, we've got number 1 and number. Don't let that confuse you. Mm-hmm. We just have some minus number. Excuse me. Let me undo that and push us back down. We simply have some number minus some number, and then we're going to square that. Okay, so that's how we're going to start out over there. We've got x for object 1. Mm-hmm. So here we are with object 1. So we'll take his x, and we need to do a subtraction. So I'm going to pull out a subtraction node. Finally, we get to use a subtraction node. And he's got this number, and we'll take away that number. So there's our two inputs, input 1 minus input 2. So x sub 1. So let's work our way across. So here we are, x sub 1. Start mm-hmm. there. So we'll plug him over here into a subtraction node. Okay?
All right.
So there he is. We got that. We got that. But we now need to hook up this guy, x sub 2. Mm-hmm. Down here, agreed?
That's right.
All right, just want to make sure you agree. So now we have, with this very teeny network, we have reproduced that. Agreed? Mm-hmm. We don't have this.
Not yet.
We just have the subtraction taking place. But we can go ahead and finish it because now we're going to take the result of that. So here's our result. Mm-hmm. And we need to do what? We need to come over to a power node, as we've already seen.
Oh, okay. I gotcha.
So here's a power node, mm-hmm. which is going to have our value in, our base, and our exponent. So we'll simply say, here's our base, guys. Okay, so we'll bring him over. And then our exponent. What do we need for our exponent?
Well, squared. Well, so you'll need...
no, you're on it.
See, I got it now. Yeah. You need a parameter.
Oh, well...
Well, a constant,
because it's not going to change.
That's right.
Okay, we could have used
solid.
We could have used a parameter, but let's think about it. Parameters are going to represent numbers that can be changed.
That's right, and you're never going to want to change
square to squared. We're not going to rewrite Pythagorean's theorem with something else because we'll definitely break it. So we'll come in here, mm-hmm. and I'm just going to put a constant in, and like I said, the way I'm going to represent that is just with a number. That's just me. Mm-hmm. So here we are. This constant contains the value 2. So I'll simply put this over into the exponent input of power. Mm-hmm. There's our output. So guess what? We have now done that. Make sense?
Yes.
So we have accomplished that. Now we need to accomplish this. So walk me through it. What do we need first?
Okay. Well, first of all, you're going to have to actually, let me think about this. Okay. I just have to reuse some of the stuff here. So, yeah, okay, you need a subtraction node.
No, I'm going to need a subtraction node.
Right.
All right, I'll buy that.
Yeah, because you're going to have to subtract just like above.
So put a subtraction in here. Mm-hmm.
Now you're going to have to plug in the y of object 1.
Okay, and that's this guy right here?
Yep.
So we'll take the y of, hang on, that looked awful. So we'll take the y of object 1, and I'll work its way down. Mm-hmm. Okay.
And the y of object 2.
Very nice. So we'll take the y of object 2. Mm-hmm. So we've just taken this guy minus this guy. All right, nice. Mm-hmm. Now what do we need to do?
Well, now you need to, you have to put in a power node again.
Very good. All right, so we're going to come over here and put in a power node. Mm-hmm. Okay, once again, base. Mm-hmm. And which is the second input call?
That's the exponent.
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 All right, very good. So we're going to take and plug what into what now?
You're going to put the subtract, or the result, excuse me, not the subtract. You need the result of those two into the base.
Okay, so we'll take our difference and we'll plug that into the base.
And you need to take the constant.
So do I need to add a new constant?
No, you can reuse that one.
And why can I reuse it?
Because it'll never change. It's the exact same constant you need.
Outstanding. So I can just plug this guy into there.
There you go.
All right, very nice. So now what we've accomplished this and this, what do we need to do next?
Well, now you need to add them together.
Outstanding. We need to add. Okay. So let's go ahead and throw in a what node?
An addition node.
So here we are with an add node. And with our add node, we'll simply take this guy. Hang on, that was awful.
Only slightly.
Plug him in. And we'll take the result here and plug that in. Mm-hmm. Okay, so now we're adding the two together.
Right.
So now we've done everything inside here. All right, so what's left?
What's left is, well, everything. You forgot to put the square root up there inside that circle. But yes, we've done everything.
No, we have not. Where's the square root at?
Oh, you totally got me, man.
Yeah, we now need a square root because in the end, it's the square root of that.
That's right.
So here we are with our square root node. We'll take this added result right here, send it right over here, and there you go.
There you go.
All right.
Look at that.
How are we doing?
Doing pretty good. I mean, that makes sense because now that big complicated math problem is simply nothing more than, 9 nodes.
All right. Now, want to trace it?
Yeah, sure.
No, I'm scared. All right. So, taking a look up here, if we sample this line, what's on it?
That would be object 1's, what is that, the X?
Yep.
Okay, so that should be 4.
Very nice. So we've got a 4 right there. What do we have right here?
That would be 0.
Okay, so we have on X is 0. Very nice. So what's taking place inside this magic box, the subtraction node?
It would be 4 minus 0.
4 minus 0.
Which, of course, would be 4.
So the result that's found over here is going to be 4. Very nice. All right, so, and what result's found right here?
That'd be 2.
2, why?
Because that is a constant.
Okay, it's a constant. Number's not going to change.
Right.
So what does it look like inside here?
That'd be 4 squared, so that would be the result of that. So that line coming out would be 16.
Okay, so being felt over here is going to be a value of 16. So far, the trace is working out nicely. Let's back up now. So over here, since we know that we've got a 0 felt there, so we need to find out what we got felt down here.
That would be 0.
So this would be 0. Again, because that's coming from y of object 1. And then all the way down here, this guy is going to be what?
3. I was just wondering if you have room to do it.
It's going to be a 3.
There you go.
Right there. And I'll put that in a circle so everybody knows. All right, very good. Because, again, this is y, the bottom one y, the top one's x, and there's y. So there's our 3. So inside our subtract node, what do we have?
0 minus 3.
0 minus 3. So what does that give us?
It'd be a negative 3.
Very good. So we got a minus 3 being felt on the line right here. All right, so that brings us over to the power node. So inside the power node, we got a minus 3 squared. Very good. So coming out of the power node, what do we have?
9.
Very nice, Terry. And then inside over here, we've got what?
16 plus 9.
Outstanding. So coming out, we have
25.
Fantastic. So what do we have taking place inside this node?
Square root of 25.
Outstanding. And then finally, what do we have coming out?
5.
5.
Yeah.
Excellent job, Terry.
Thank you.
You've just traced the entire thing.
Yeah, and it was much simpler to do it this way than it was to look at all, the numbers and doodads.
The crazy numbers. Okay, so does all this make sense? I mean, it is really just like everything we've been doing with the nodes and networks up to this point. Building a computer, building chocolate cake or chocolate chip cookies. Chocolate chip cookies, yeah. We were just connecting a bunch of things, but here we're starting to deal with data. We've been dealing with numbers. But the idea is the same.
Right.
We're simply taking these numbers, feeding them into nodes that perform some sort of operation on that data or on that number, and then spit out a result. No different than taking chocolate and milk and mixing them together, and we get a result.
That's right.
Okay? Any questions?
No, it makes complete sense to me.
Okay, so with that, I'm just curious, how much writing have we managed to do? All right, that's looking nice. And wait, we have more? Oh, yeah. So, yeah, it looks like we stayed pretty busy in this particular one. So, ladies and gentlemen, this is going to wrap up we can turn that back on because it looks cool. This is going to wrap up the second video in the little 3-part mini-series on thinking procedurally. In the last video, we're just going to quickly take a look at a procedural network inside of Houdini. I'm not expecting you to understand Houdini or even know everything that I'm talking about. I'm just expecting you to understand the network I'm pointing to and what's taking place. And it should be quite easy after everything we've looked at. So with that is going to wrap up this video. Thanks a lot.